Algebra 2A, 4.6, quadratic formula. This video specifically made for Riley B. Good luck at state POMs. Okay. So we're going to use our quadratic formula to solve equations of the form ax squared plus bx plus c equals 0. The quadratic formula itself is x equals negative b plus minus the square root of b squared minus 4 times a times c, all of that divided by 2a. That's a big nasty formula to remember, but we use it to find the roots or the zeros when we want exact answers that don't come out nice, that you can't just like graph on the calculator. Alright, like we're used to doing this and doing second trace, alright, and then getting our answers this way. Okay, what if I don't want a rounded answer of 5.3? Okay, I want to know what it is exactly. Okay, we're going to use this. All the stuff under the square root is called the discriminant. That b squared minus 4 times a times c is called the discriminant. Okay? You can tell a lot about your function from just looking at that. Okay, at that discriminant. Okay? And this part of the notes is also, it's a chart in the book. Okay? Which probably would have a lot nicer handwriting than this. And it has some pictures to go with it. But we'll discuss it here anyways. Okay, if you put in the B and the A and the C, and this comes out as a number greater than 0, it's positive, and it's a perfect square, like 25, 81, 100, something like that, then your answers will be two real, rational roots. Okay, real means not imaginary. Rational means that you can write it as a fraction, which means those are usually our nice numbers. Okay, those will come out as like 4, negative 3, 1/2, something like that. Okay, if it's positive, b squared minus 4ac is positive, but not a perfect square, then you're going to have two real irrational roots. Not that nice. Okay, they're real, they're not imaginary, but they don't come out nice. So like the square root of 3, or the square root of 17, or something weird like that. If under the square root it equals exactly 0, b squared minus 4ac equals 0, we're only going to have one real root. How does that happen? Okay, your graph would look something like this. It's only going to touch it just one time. Okay, that's what your graph would look like, something like that. So that would be that kind of a situation when this would only, when your discriminant would equal 0, and you're only going to have one real root. Okay, and then we have the situation where we get a negative number under the square root. b squared minus 4ac is less than 0, means it's negative. Okay, and now we have the power to do the square root of a negative number. Okay, it's going to come out as a complex root, or it's going to have an imaginary part, right? We're going to have I involved in some way. Okay. Give you a second there. If you want more time to write that down, you can go ahead and hit pause and finish copying that stuff down. Otherwise, this is in the book. Probably a lot easier to read there. All right, now what you came for, the practice problems. Okay. We'll get you started here with this one. We have 15x squared minus 7x minus 4 equals 0. You're going to have some problems where you just find the determinant, not determinant, discriminant, and then determine the number and type of roots. Okay, that's it. All right, so 15x squared minus 7x minus 4 equals 0. There's A, there's B, take the negative sign with it. There's C, take the negative sign with it. Okay? So my discriminant is going to be b squared minus 4 times a times c. So we have negative 7 squared minus 4 times 15 times negative 4. Okay, type all that in. And it should come out as 289. Okay, so it's positive. So we're going to have two real roots. Now, are they going to be rational roots or irrational roots? I don't know. Is 289 a perfect square? Square root of 289 is 17. It comes out nice, so yes, that means it is a perfect square. So what does that mean for me? It means I'm going to have two real, rational, nice number roots. Okay? Two real rational roots. All right, you try over here. 7x squared minus 11x plus 5 equals 0. Go ahead and hit pause and give that one a shot. All right, welcome back. Here's what you should have got. Okay, A, B, C. So negative 11 squared is 121 minus 4 times 7 times 5. You're going to get negative 19. Uh-oh, negative number. You're going to have two complex roots. And that's all the problem wants. Okay, find the discriminant and then describe the number, 2 or 1, and then the type of roots you're going to get. Okay, next type of problem. It's going to have three parts to it instead of just two, but those first two parts are still the same. Step 1, find the determinant. Step 2, determine the number and type of roots. That's what we've just been doing. Piece of cake. Step 3, find what those roots are using the quadratic formula. Alright, so that's one new thing there. We're going to finish off the formula. Okay, so let's get started. There's b. Make sure you take the negative sign with it. Okay, so b squared, we got negative 3 squared minus 4 times a times c. 9 minus 8 is going to be 1. 1 is a perfect square. 1 times 1, or 1 squared, is 1. So it's a perfect square. Means we're going to have two real rational roots. Okay, so that's part 1 and part 2. What about part 3, actually finding it? We're going to have to actually use the full formula here. Negative b plus minus square root b squared minus 4 times a times c. All of that whole thing, divided by 2a. Alright, a lot of kids will only put the 2a over there. They won't have the negative b as part of that big fraction. Okay, all of it gets divided by 2a. Okay, so negative b. Well, b is already negative, so it's going to be negative of a negative 3. It's going to make it be positive. Plus minus, well, I already did this part. I already did b squared minus 4ac. That's what I did right here. It was 1. Over 2 times a. My a is 2. Okay, so negative of a negative 3 is actually positive 3. Plus minus, the square root of 1 is 1 over 4. 3 plus 1 is 4 over 4. That's going to be 1. 3 minus 1 is 2 over 4, and that's a half. Okay? Two real rational roots. Rational means you could write it as a fraction. Here they are. Okay, and nice numbers. Half is not bad. 2/4 is not bad. Those are good numbers. Those are nice fractions. Okay, it's not like it's 17/19ths or anything ridiculous. Okay. Now this next one, I'm going to ask you to try it on your own first, but it is a little bit more difficult. But just give it a shot and see what happens. The tough part is in the reducing. Okay, the tough part is in the reducing. It shouldn't be tough to figure out. the first, all three parts, but just reducing the third part might be a little difficult. Okay, hit pause and give it a shot. All right, welcome back. Let's do it to it. A, B, C. All right, we're going to have 4 squared minus 4 times 2 times 7. That's going to be 16 minus 56. Uh-oh, negative 40. Yuck. 2 complex roots. 2 complex roots. We're going to have i's. All right, so negative b, that's going to be negative 4, plus minus the discriminant. I just did that, negative 40, all over 2 times a, 2 times 2. Okay, I'm going to break this down over here on the side. Okay, if it's intimidating to try to just keep it in line, you can go off on the side. Square root of negative 40. What goes into 40? Perfect square that goes into 40. 25, no. 16, no. 9, no. 4, yes. And I like to put the negative on the perfect square. Okay, I can do the square root of negative 4, that's 2i. Can't do the square root of 10, it stays. Okay, that was the tough part. Not that scary, huh? Negative 4 plus minus 2i radical 10 over 4. Okay, something in common here. They're all even, so you could divide them all by 2. Negative 2 plus minus I radical 10 over 2. That's where I would stop, because I think that looks nicer. The book would probably break it up separately. You do negative 2 over 2 for negative 1, and then this over 2. But I don't think that looks very good. I like this one better. Okay, but either one is right. Either one is right. Okay, if you left it here, that might be like a minus a half on a quiz or a test. All right. So there you go. There's a few more examples in the book if you want to look at those. There is the homework. We decided to skip number 24. So we got page 270, 27 through 40. Skip number 24. All right. Get that homework done, Lions.